So here it is told that A is a set. Set A is 1, 2, 3, and 4. Then, and R is a relation on the set A. So R is a subset of A cross A, where the relation R is defined as it contains the ordered pair A comma B comma C comma D. So if 2A plus 3B, that is equal to 4C plus 5D. So therefore, it means that A comma B is related to C comma D only if this condition is satisfied. So suppose and A, B, C, and D should belong to the set A. A, B, C, and D should belong to the set A. So A, B, C, and D, they should go from 1 to 3, should be 1 or 2 or 3 or 4. Okay. So therefore, if we take A and B and C and D, what we should take? So let's say we take AB as 3 and 1. Then 2 into 3 plus 3 into 1, that is 6 plus 3, that is 9. And 4 plus 5 is also 9. So I can take C and D as 1 and 1. Similarly, we can take A as 2 and B as 3. Then we will get 2 into 2 plus 3 into 3. That is 4 plus 9, that is 13. And then here also, we can take uh, we can take 4 to the 8 or 4 ones of 4, 5 to the 10, 2 and 3, and 2 and 1. Since why? Then also 4 into 2 is 8 plus 5 is also 13. Then A and B we can take 4 and 2. Then it will be 2 into 4 plus 3 into 2, that is for the 8 plus 6, that is 14. And then we can take 1 and 2. C and D is 1 and 2. Since why 4 plus 10 is also 14. And then we can take A as 1 and B as 4. Since why 2 into 1 plus 3 into 4, that is 3 for the 12 plus 2, that is also 14. And C and D we can take 1 and 2. And A and B here we can take 4 and 3. Since why 2 into 4, 2 into 4 plus 3 into 3, that is 8 plus 9, that is 17. Then here also this will be 3 and 1. Since why we can take, we can tell 4 3s are 12. 12 plus 5, that is equal to also 17. And also we can take 3 and 4. Since why 2 into 3 plus 3 into 4, that is 3 for the 12, 12 plus 6, that is 18. And then here we can take 2 and 2. Since why 4 into 2 plus 5 into 2, that is 4 to the 8, 8 plus 10 is also 18. So it means there are 6 pairs, 6 ordered pairs in the relation R. Therefore, so we can take, so there are 6 elements in the relation R. So the answer will be 6 here. Then here so here it is told A is the set -4, -3, -2, 0, 1, 3, and 4, where R is the set of the ordered pairs A and B, such that B equals to mod A, or B square equal to A square plus 1, B square equal to A plus 1. So it means A is related to B only if this condition is satisfied. Then the minimum number of elements that must be added to the relation R, so that it becomes reflexive and symmetric is. So therefore, first we have to write the elements in the relation R. So therefore, we can take obviously A and B. So we can take -4, 4 and -3, 3, -2, 2, or actually 2 is not there, so we cannot take. Mm, okay, so then we can take B square equals to A plus 1. A plus 1. So 0 plus 1 is 1 square. So it means we can take 0 and 1. 0 plus 1 is equal to 1 square. Then we can take A as 3. Then 3 plus 1 is 4, which is -2 square. So 3 comma -2 also we can take. And then 4 and 4 also we can take, and 3 and 3 also we can take, and 0 and 0 also we can take, 0 comma 0 and 1 comma 1. Since y mod of A will be equal to B, then we can take 3 comma 3, 4 comma 4, 1 comma 1 and 0 comma 0, 3 comma -2 and 0 comma 1. So here we have 3 plus 3, 6, 6 plus 2, 8 elements. Eight elements are there. So here, as we can see that it is not reflexive, since 1 comma 1 is there, 0 comma 0 is there, 3 comma 3 is there, 4 comma 4 is there, but -2 comma -2 is not there. So this we have to add, and -3 comma -3 also we have to add, and -4 comma -4 also we have to add. So these we have to add, and then it will be reflexive, and it will be symmetric if -4 comma 4 is there, but 4 comma -4 is not there. So this we have to add, and 3 comma -3 also we have to add. 1 comma 0 is not there, we have to add that, and -2 comma 3 also is not there. So these we have to add. So therefore it means 1, 2, 3, 4, 5, 6, 7. So 7 elements should be added. 7 elements should be added to the relation R, so that it is reflexive and symmetric. So that it is reflexive and symmetric. So the answer will be 7. Then here it is told that the number of relations on the set 1, 2, 3 containing 1, 2 and 2, 3 which are reflexive and transitive but not symmetric is. So it means the relation should contain 1, 2 and 2, 3. So it has to be reflexive, so it should contain 1, 1, 2, 2 and 3, 3 obviously. 3, 3 obviously, and obviously should contain 3, 3, and it should be reflexive, and it should be transitive. So it means 1, 2 is there, 2, 3 is there. So 1, 3 also should be there. And okay. So we can put 1, 3. So this is one relation R1, and R2 we can take 1, 1, 2, 2, 3, 3, and then 1, 2, 2, 3, 1, 3. So we can add 2, 1, 2, 1 we can add, 2, 1 we can add, but 3, 2 is not there, so it is not symmetric, but it is transitive since 2, 1 is there, 2, 1, 3 is there, so 2, 3 is also there. Then one more relation we can add, that is 1, 1 we can do, 2, 2 we can keep, and 3, 3 we can keep, and 1, 2 we can we have to keep, and 2, 3 also we have to keep. 1, 3 we can keep, and instead of 2, 1 we can keep 3, 2. So it means that it is also not symmetric since 1, 2 is there, but 2, 1 is not there. So these are the three relations we can have. So 3 is the correct answer. Then here it is told the number of elements in the set n belongs to z mod of n square minus 10n plus 19, that is less than 6. So if we remove the absolute value, then we will get n square minus 10n plus 19, that should be less than 6 but more than minus 6. So therefore we can tell that n square minus 10n plus 19 less than 6, and also, and so here and function should be used. It means we have to take the intersection of these two solution sets. So one is n square minus 10n plus 19, it is more than minus 6. So it means that n square minus 10n plus 13, that is less than 0, and n square minus 10n plus 25, that is greater than 0. So this will be so from here we can say that here we have, here also we will get two roots, and here also we'll get, here actually this will be n minus 5 whole square, that is greater than 0. So which will be obviously more than 0 only. It means that here n should not be equal to 5. So except 5, any number if you take, it will be greater than 0 only. So here n belongs to z minus 5. Since here it is told n should belong to z. And n square minus 10n plus 13 equal to 0. Here the roots will be n equal to minus b plus or minus square root of b square minus 4ac, 13 4s are 52 by 2a. So this will be 10 plus or minus b square minus 4ac. So 100 minus 52. 100 minus 52, so that will be equal to 48. So 100 plus or minus 48 by 2. So this will be 5 plus or minus. So this is 16 3s are 48. So this is 4 root 3. 4 root 3 by 2, that is 2 root 3. 5 plus or minus 2 root 3. So therefore I can, so these are the two factors for it, which are n minus of 5 minus 2 root 3 into n minus 5 plus 2 root 3, that is less than 0. This is less than 0. It means n should be more than 5 minus 2 root 3 and less than 5 plus 2 root 3. So now 2 into root 3 is how much? That is approximately 2 into 1.732 approximately, which is 3.4 3.464. So 5 minus 3.5, that is equal to 1.5. So n should be more than, this is more than nearly 1.5, but less than 5 plus 3.5, which is less than 8.5. So therefore we can say n should be how much? It should be, so n can be either and n belongs to z also, it is told n should be an integer. So n can be 2, 3, 4, 5, 6, 7, 8. It means the number of elements in this set, and here it is also told that n should not be 5. So therefore this 5 we should exclude. Then so it is, so there are 2, 3, 4, 6, 7, 8. So there are 6 elements in the set S. 6 elements are there in the given set. So 6 is the correct answer. And here it is told that let, let A equals to, let A equals to the set 0, 3, 4, 6, 7, 8, 9, 10. And R be the relation defined on the set A. So it means R is a subset of A cross A. And it is told X is related to Y if X minus Y is an odd positive integer. It means it is of the form 2m plus 1 for where m is a whole. So 2m minus 1 where m should be a natural number. Since y should be an odd positive integer, or x minus y that can be equal to 2. X minus y that can be equal to 2. So it means that x minus y either should be equal to 2 or it should be an odd positive integer. Then the number of elements that must be added to the relation R so that it is a symmetric relation is equal to the number of elements that should be added to the relation R. The number of elements that should be added to the relation R. Okay, so now first we have to find which elements are there in the relation R. So x minus y, that should be odd. So as you know that the difference in between x and y, that is odd. It means that one is odd, one is even. So we can do odd minus even, then only it will be odd. And here x minus y, that should be either odd minus odd, or it should be even minus even, and they should be consecutive. They should be, so it means that x and y should be consecutive odd numbers, or x and y should be consecutive even numbers. Then only their difference will be 2. So the relation R will contain the numbers 3 minus 0, which is odd. 4 minus 0 we can't keep. 6 minus 0 we can't take. 7 minus 0 we can take. And then 8 minus 0 we can take. 9 minus 0 we can take. 9 minus 0 is an odd number. So it means 9 comma 0 we can take. And then 10 minus 0 we cannot take. Now with 3, so 3 minus 3 we can't take. 4 minus 3 we can take. 4 minus 3 we can take. 4 minus 3 is 1. 6 minus 3 is also 3. 6 comma 3 we can take. 7 minus 3 is 4, we can't use. So 8 minus 3 is 5, we can take that. 9 minus 3 is 6, we can't use. 10 minus 3 is 7, we can take that. Then with 4, we can take. 4 minus 4 we can't take. 6 minus 4 we can take, since 6 minus 4 will be 2. 6 and 4 we can take. 7 minus 4 also we can take. Then 8 minus 4 we can't take. 9 comma 4 we can take. 10 comma 4 also we can't take. Then with 6, 7 minus 6 we can take. Then 8 minus 6 also we can take. And 9 minus 6 also we can take. And 10 minus 6 we can't take. Then with 7, 8 minus 7 we can take. Then 9 minus 7 also we can take. 10 minus 7 also we can take. Then with 8, 9 comma 8 we can 9 comma 8 we can take, and 10 comma 8 also we can take. And then with 9, 10 comma 9 also we can take. So there are how many elements? The number of elements in the relation R. So that will be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. 10, comma 0 we can take, and then 9, comma 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. 4 and 3 we can take, 6 minus 3 we can take, 7 minus 3 we can't take, 8 minus 3 we can take, 10 minus 3 we can take, 6 minus 4 we can take, 7 minus 4 we can take, 9 minus 4 we can take, 7 minus 6 we can take, 8 minus 6 we can take, 9 minus 6 we can take. Okay. So there are 19 elements in the relation R. So we have to make R a symmetric relation. So it means that 0, 3 is not there, 0, 7 also is not there, 0, 9 is not there, 3, 4 is not there, 6, 3 is not there. So it means that 19 elements only we have to add. We have to add 19 elements so that it is symmetric. Since why? Since here 0, 3 we have to add, and then 0, 4 also, 0, 7 we have to add, then 0, 9 we have to add, and then 0, no, 3, 4 we have to include, and then we have to include 3, 6 also, and 3, 8 also. Since y, if it is symmetric, it means that if x is related to y, then y also should be related to x. 6, 3, 8 is not, we have to add, and 3, 10 also we have to include, then 4, 6 we have to include, and then 4, 7 we have to include, 4, 9 we have to include, then 6, 7 we have to include, 6, 8 we have to include, 6, 9 we have to include, 7, 8 we have to include, 7, 9 we have to include, 7, 10 we have to include, 8, 9 we have to include, then 8, 10 also we have to include, and then 9, 10 also we have to include. So it means, so as to make it symmetric, all these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 elements only we have to include. We have to add. So it means the answer will be 19. Then here it is told that let A be the set 1, 2, 3 till 10, and then B is the set 0, 1, 2, 3, 4. The minimum number of elements in the relation are, so here it is told A is related to B if 2 into A minus B whole square plus 3 into A minus B, that belongs to B. For all A belongs to A, yeah, for all A and B, for all A comma B belongs to A. A comma B should belong to the set A. Now this this 2 into A minus B whole square plus 3 into A minus B, that we can also write it as A minus B I can take as common, then we can write into 2A minus 2B plus 3. 2A minus 2B plus 3. So this will be So here we can take, so this should belong to B. It means it can be 0 also. So it means the same elements we can take. It means we can take 1 comma 1, 2 comma 2 till 10 comma 10 we can take. So here we have 10 elements. Then this is 2 into A minus B plus 3. And then A minus B can be equal to 1. Since why? Then A minus B into 2 into A minus B plus 3, 2 into A minus B plus 3. So that will be equal to 1 into 2 plus 3. So that is equal to 5. And 5 is an element. 5 is not an element in the set B. 5 does not belong to set B. So A minus B can't be 1. And then if A minus B equal to, it can be 1, 2, 3, 4, or 5. No. A minus B, it can be minus 1 also. If A minus B is minus 1, then minus 1 into 2 into minus 1 plus 3. So that is equal to 3 minus 2, that is 1, that is equal to m- minus 1, which also does not belong to the set B. And then if A minus B that is equal to 2, then we can say that 2 into 2 plus 3. So that will be 4 plus 3, that is 7, 7 into 2, that is 14. So 14 also does not belong to the set B. Then if A minus B that is equal to minus 2, then we can say that it will be minus 2 into 2 into minus 2 plus 3. So this will be minus 2 into minus 4 plus 3, that is minus 1. So this will be equal to 2, which belongs to um, the set B. So therefore A minus B equal to minus 2 we can take. Now A minus B, if it is minus 2, then we can take the pairs 1 comma 3, 1 comma 3, and then 2 comma 4, and 3 comma 5, and 5 comma 7, and 6 comma 8, and then 8, then yes, then 7 comma 9, and 8 comma 10. So it means here we have 1 2 3 4 5 6 7. Okay, yeah, so here we can also include 4 comma 6. So therefore here we have 8 elements, and then if we take A minus B as 3, or say let's say minus 3, then the value of A minus B, that is minus 3 into minus 3 plus 3, no, that is minus 6 plus 3, that is equal to minus 3. So minus 3 into minus 3, that is 9, which does not belong to the set B. So it means that till here only we have to check. Since why, if A minus B, if we take some higher values, then it will be it will be outside the range from 0 to 4. So therefore it means the total number of elements in the set R, the total number of elements in the relation R, is 8 elements plus 10 elements, which is 18 8 elements plus 10 elements, that is equal to 18 elements. 18 elements. So it means that 18 is the correct answer. And here it is told that S is the set 1, 2, 3, 5, 7, 10, 11. Then the number of non-empty subsets of S such that uh, that have the sum of all the elements a multiple of 3. So now any number can be written as either 3k or 3k plus 1 or 3k or 3k plus 2, where k is some in, integer, where k is some integer. Since why, if any number can be either divisible by k, or if it is not divisible by k, then it will uh, either have the remainder 1 or the remainder will be 2. So now therefore the so here non-empty subsets, it means that it can contain one element. Yeah. So from here the elements which are of the form 3k, elements of the form 3k in the set S are 3. So only 3 is there. It's 3 only. And then the elements of the form 3k plus 1 in the set S are 3k plus 1, that is 1, then 7, then 10. And then elements of the form 3k plus 2 in the set S are that is 2, and 3 1 are 3, 3 plus 2, that is 5, and 3 3 are 9 plus 2, that is 11. So 2, 5, and 11 are in the set S, which are of the form 3k plus 2. Now the subsets, so then the number of subsets containing only one element, the number of subsets of S containing only one element, so that will be equal to S1, that is 1. Since why, only it should contain 3, only should have 3, then only the sum of all the elements will be a multiple of 3. And the number of subsets of S containing only two elements, so that will be S2. So we can take one from this 1, 7, and 10, and one from 2, 5, and e- e- 11, then only it will be divisible by 3. So out of these 3 elements, we can choose any one element by 3c one ways, and from here also we can choose one out of any 3 elements in 3c one ways. So that will be 3 3s are 9. There are 9 sets, 9 subsets of S which contain only 2 elements, and then number of subsets of S containing 3 elements, so that will be S3, that is equal to containing 3 elements. So here we can select 3 and any 2 from these, any no, we can select the number 3 and we can select any one from here and any one from here. So that will be equal to 3c1 into 3c1 into 1. No, 3c1 into 3c1, it is okay. So we chose one element from here and one element from here, and three elements. You have to choose one element, which is 3. And also we can take all these 3 elements, then also we will get multiple of 3. So that is in one way. And here, from here also we can choose all the 3 elements, 2, 5 and 11. Then also the sum will be multiple of 3. So that will be in one way. So that will be 1 plus 1, 2 plus 3, 3 is 9. That is 11 sets. There are 11 subsets of S containing 3 elements, and then the number of subsets of S having 4 elements. Having 4 elements, that will be S4. The number of subsets of S containing 3 elements. Number of subsets of S having 4 elements. 4 elements we have to choose. So it means we have to choose all 3 elements from this, and 1, 3 we have to choose, and all elements from this, and 1, 3 we have to choose. So that is one way and one way. And we can also choose 2 from here and 2 from here. Since why it will be 2, 3k plus 1 plus 3k plus 1, that will be, so we can take 2 from here and 2 from here. Since why, then we will get 3k plus 1 uh, plus 3k plus 1, that will be 3k plus 2. Means from these two if you take, then we will get like 3k1 plus 1 plus 3k2 plus 2 plus this will be 3k1 plus, or I can take 3k, let's say 3k1 dash plus 2 plus 3k. Actually, what is happening? Suppose if you take one one number which is leaving remainder 1, and if you take two numbers which leaves remainder 1, then their sum of the remainders will be 2. And from here, if you take two numbers where it leaves the remainder 2, then the sum of the remainders will be 2 plus 2, 4. So it means actually then the remainder will come 1 if we divide it by 3. And so here and here the sum of the remainders will be 6. So it means there will be no remainder when we divide by 3. So it means we have to choose 1 or 2 out of this 1, 7 and 10, and 2 out of 2, 5 and 11. So it will be 3 to 2 into 3 to 2. So this will be also 2 plus 3, 3 is 9. So that is also 11 sets. There are also 11 sets. And then we have to find the number of subsets of S having 5 elements. So that will be, if you have to choose 5 elements, then so we can select any 2 from here, any 2 from here, and this 3. So it will be 3c2 into 3c2 into 1. So this will be 3 c 9 sets. And then we have to find the number of subsets of S containing 6 elements. Therefore, now the number of subsets of S having 6 elements. So that will be equal to, so we can choose from here, we have to select all these elements and all these elements. So that will be, since here the sum of the remainders will be 3 and here the sum of the remainders will be 6. So there will be no remainder when we divide them by 3. So we have, so it will be in one way only. And then the number of subsets of S having 7 elements. So then we have to take all these elements in the set S. So that is only one way. So therefore the number of non-empty subsets of S having the sum of all the elements a multiple of 3. So therefore the number of subsets which is non-empty subsets of S having the sum of all elements multiple multiple of 3, that will be equal to this is this will be equal to 1 plus 9 plus 11 plus 11 plus 9. 1 plus 9 plus 11, 1 plus 9 plus 11 plus 11 plus 9, then plus 11 plus 11 plus 9, plus it will be 1 plus 1 plus 1 plus 1, so it will be 3 plus 9 to the 9 to the 18 plus will be 11 to the 22, so this will be 21 plus 22, so that will be 43. That means there are 43 non-empty subsets of S having some of the elements a multiple of 3. So 43 is the answer. Then here it is told the minimum number of elements that must be added to the relation A comma B, B comma C, B comma C, B comma D on the set A, which is A B C D, so that it is an equivalence relation is. So we have to get R an equivalence relation. So then okay, so it is an equivalence relation. So it means that R should be reflexive, symmetric, and transitive. So now it means that A comma A should be there, B comma B also should be there, C comma C also should be there, and D comma D also should be there. Then only R will be reflexive, and it should be symmetric also. It means that A comma B is there, so B comma A also should be there. B comma C is there, so C comma B also should be there, and B comma D is there, so D comma B also should be there. Then only R will be symmetric, and it has to be transitive also. So it means that AB is there and BC is there, so AC also should be there, and AB is there, BD is there, so AD also should be there. And since AD is there, so DA also should be there since it has to be symmetric, and AC is there, so CA also should be there since it has to be symmetric, and AD is there. Okay, DB is there, so AB is there. AC is there, CB is there, so AB is there. So AC and AD also should be there. CA is there, AB is there, so CB also is there. BA is there, AC is there, so BC is also there. So AC and AD also should be there. BA is there, AC is there, so BC is there, so DA is there, AB is there, so DB also should be there. DB also is there, and then DB is there and BC is there, so DC also should be there. DB is there and BC is there, so DC also should be there. And DC is there, so CD also should be there. DB is there, BD, okay. CB is there, BD is there, so CD also is there, okay. So these elements also has to be added, then R will be transitive also. R will be a transitive relation also. So it means that we have to add 1, 2, 3, 4, 4 plus 3, 7, 7 plus 1, 2, 3, 4, 5, 6, 6 elements. So it means 13 elements we have to add in, in order to make the relation R an equivalence relation. Since why? Then only it will be reflexive also, symmetric also, and transitive also. Then only the relation R will be an equivalence re relation. So it means 13 elements we have to add. So 13 is the answer. So here it is told that let R be a relation on the set A, which is 1, 2, 3 till 60 to itself. So R is a subset of A cross A. So A is related to B if B equals to PQ, where P and Q belong to where P and Q is greater than or equal to 3 and which are prime numbers. So it means P and Q should be a prime number more than or equal to 3. So now if we take P as 3, then Q can be 3, 5, 7 till 19. So it will be 3, 5, 7, then 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 19. So it means we have 1, 2, 3, 4, 5, 6, 7 options. 7 options here. Since why 3 into 19 only, it will be 57. And since B should be always less than or equal to 60, B can't be more than 60. Since A and B should belong to A, the set A. Now, if P equals to 5, then Q can be 5. Q can be 5 then it can be 7, it can be 11. It cannot be 13 since 13 5 is a 65. So it has got three options. And now if p equals to 7, then q can be, you can be 7. Q cannot be 11. So q can be 7 only. So we have only one option. So therefore it means for b we have here we have 7 options, we have here 3 options, here 1. So we have 7 plus 3 plus 1, which is 11 options. So b, for b we have 11 numbers, and for a we have all 60 options. We have 60 options since a can be any number from 1 to 60. So therefore the number of elements in the relation R, therefore the number of elements in R in the relation R is same as the number of subsets of R. No, it is same as the number of ordered pairs in the relation R. So it means that will be 60 into 11. Since for A we have 60 options, for B we have 11 options. So it will be 660 elements. So option B is the correct answer. Then here it is told that for alpha belongs to n, consider a relation R on the set n given by x is related to y if 3x plus alpha y is a multiple of 7. 3x plus alpha y should be a multiple of 7. 3x plus alpha y should be a multiple of 7. The relation R is an equivalence relation if and only if. So we have to find alpha. We have to find what is alpha if R is an equivalence relation. So now if R is an equivalence relation, then R should be reflexive. R should be a reflexive relation. It means that R should be reflexive. It means that x should be related to x. So it means that 3x plus alpha x should be a multiple of 7. A multiple of 7. So it means that x into 3 plus alpha, should be a multiple of 7. Multiple of 7. So therefore, it means that 3 plus alpha, that should be equal to 7 into some k, where k is some natural number. So alpha should be equal to 7k minus 3. Let's call it k1. 7k1 minus 3. Or I can say alpha should be of the form 7k1 plus 4. And R should be symmetric also. R should be symmetric also. So it means that A is related to B. Which implies that B is related to A. So it means that 3A means that 3x plus means that x is related to y. It also means y should be related to x. Means 3x plus 7k minus 3, since alpha is of the form 7k minus 3 into y, that should be equal to 7m for some natural number m. So therefore 3 into x minus y plus 7ky, that should be equal to 7m. It means what? 3 into now if y is related to x, it means that 3 into y minus x plus 7kx, that should be also equal to 7m. So this should be also a multiple of 7. Now y minus x, we can say, so from here we can say that this 3 into y minus x, that is also equal to 7ky minus 7m. So this is 7ky minus 7m plus 7kx. So which is also a multiple of 7. So it means that R is symmetric relation. And so it means that alpha should be 7k1 minus 3 form, then only R will be symmetric also. And then for transitive, we should have that if x is related to y and y is related to z, then x should be related to z. So now 3x plus 7k minus 3 into y, that is equal to, let's say this is 7k1 and 3y plus here you can say 7k let's say this is k2, 3k2, 7k2, where k2 is some uh, natural number. This will be 3y plus 7k2. Okay. 7k dash minus 3 or 7k minus 3 into z, since y is related to z, let's say that is equal to 7k3. Then if we add these two, then we will get 3x plus 7ky, since 3y will minus 3y will get cancelled, and then plus this is 3y plus this is 7kz plus 7kz minus 3z, that is equal to 7k3. Okay, this will be 7k3 plus 7k2. This will be 3x plus so the yeah, so 3x into 7k minus 3 into z, that will be equal to also 7k3 plus 7k2 minus 7ky, so which is also a multiple of 7. So therefore x is also related to z. So therefore alpha, so therefore r is transitive only if alpha is of the form 7k1 minus 3, or I can say it is of the form 7k1 plus 4. So it means that 4 is the remainder when alpha is divided by 7. Since alpha is of the form 7k plus 4, so it means when alpha is divided by 7, the remainder should be 4. So option D is the correct answer. Then here it is told, let R1 and R2 be two relations defined on the set of real numbers R, which is defined by A R1B AB greater than or equal to 0 and A R2B A is greater than or equal to B. So here it is told that A is related to B under the relation R1 if AB is greater than or equal to 0 and A is related to B under the relation R2 if and only if A is greater than or equal to B. And this is applicable for all A, comma B belongs to the set of real numbers R. So then R1 is equivalence. Okay, so which one is an equivalence relation that we have to find out? So now A is related to A under the relation R1, since why A square will be always greater than or equal to 0. So R1 is reflexive. R1 is reflexive. And A is related to B under R1 also implies that B is related to A also, since why AB is equal to BA, AB and BA is same thing, that will be greater than or equal to 0 only. And if A is related to B and B is related to C under the relation R1, then it does not imply that A will be related to C. Since why? For example, suppose we tell that 1 is related to 2 and 2 is related, uh, suppose we tell, yeah, 1 is related to 2 and okay. Suppose we take -1 is related to 0 and 0 is related to 2, but -1 is not related to, but if I tell -1 is related to 2, then that is wrong, since why? -1 into 2, that is less than 0. So it means that R1 is not transitive. R1 is not transitive. which means that R1 is not equivalence relation. R1 is obviously not equivalence relation. So here it is told, so it means that uh, A and C are not correct only. So it means that out of B and D we have to check. It means that we have to check R2 also. So now R2, for R2 it is told A is greater than or equal to B. Now A is greater than or equal to A of obviously, since they are same. So it means that R2 is reflexive. R2 is reflexive. And A is, if A is related to B under the relation R2, it means A is greater than or equal to B, then B is not greater than or equal to A. So B is less than or equal to B. So R2 is not symmetric. R2 is not symmetric. So hence it means that R2 is also not an equivalence relation. R2 is also not an equivalence relation. So it means that neither R1 nor R2 are is an equivalence relation. So option D is the correct answer. Okay, here it is told that let this let us set A equals to A1 union A2 union till AK, where AI intersection AJ that is equal to phi. Means that it means that all are disjoint sets for I not equal to J. I not equal to J and I comma J greater than or equal to 1 and less than or equal to K. So it means that all these sets are disjoint sets. It means they have no intersection. Then it means all they are mutually exclusive actually. It means they are mutually disjoint sets. They are mutually disjoint sets. Okay. So then define the relation R from A to A. R is a R is a relation from A to A, which is defined as X is related to Y if Y belongs to AI, if and only if X belongs to AI. So Y belongs to AI if and only if X belongs to AI, where I goes from 1 to K. Then R is. So R is reflexive. R is obviously reflexive since Y, since if X is, since X is related to X, since if X belongs to AI, then obviously X will belong to AI also. So same thing. So R will be reflexive and R is symmetric also. R is symmetric also since Y. Since if X is related to Y, it means that Y is also related to X. Since if we tell Y X belongs to AI, it means if and only if Y belongs to AI, it also means that Y belongs to AI implies means if and only if X belongs to AI. So R is symmetric also. And the relation R is transitive also. R is transitive also since Y if X is related to Y, it means and Y is related to X, Y is related to Z, then it implies that x is also related to z. Suppose, yeah, since why? Since if x belongs to AI, if and only if belongs to AI, implies that if y belongs to AI, it also and if y belongs to AI also implies that z belongs to AI, then it also implies that x belongs to AI if and only if z belongs to AI, and which also if and only if y belongs to AI. So it means that R is transitive also, and R is reflexive also, and R is symmetric also. Therefore, R is an equivalence relation. R is an equivalence relation. So R is an equivalence relation. So option D is the correct answer. Then here it is told that R1 is a relation such that A is related to B under the relation R1 if a mod of A minus B is less than or equal to 13 for all A comma B belongs to the set N, where N is the set of all natural numbers. And A is related to B under the relation R2 if mod of A minus B is not equal to 13. Then on N, both are equivalence, or which one is? So if R1 and R2 are equivalence relations, that we have to find out. Now, A is related to A, since y A is related to A under the relation R1, since y mod of A minus A is equal to 0, which is obviously less than or equal to 13. So therefore R1 is reflexive. And if A is related to B under the relation R1, then it also implies that B is related to A under the relation R1. Since why? Since mod of A minus B is same as mod of B minus A, which will be less than or equal to 13. So therefore R1 is symmetric also. R1 is symmetric. And if A is related to B under the relation R1, then A is related to B is related to C under the relation R1, then it means that A mod of A minus B is less than or equal to 13, and mod of B minus C is also less than or equal to 13. Then A will be related to C also, which will not be true, since why? For example, if you take A as 1 and B as 2, B as 2, and C as 15, or B as 3 and C as 15. So then mod of 1 minus 3, that is equal to 2, which is less than or equal to 13. So I can say 1 is related to 3 under the relation R1, and also uh, 3 minus 15, mod of 3 minus 15 is equal to 12, which is less than or equal to 13. So I can say 3 is related to 15 under the relation R1, but 1 is not 1 is not related to 15 under the relation R1. Since why? Since mod of 1 minus 15 is equal to 14, which is not less than or equal to 13. So it means that R1 is not transitive. R1 is not transitive, and hence, so I can say R1 is not an equivalence relation. R1 is not an equivalence relation. And then for R2, R2 is mod of A minus B not equal to 13. So now A is related to A under the relation R2. Since why? Since mod of A minus A that is equal to 0, which is not equal to 13. And also, so it means that R2 is reflexive. R2 is reflexive. And then if if A is related to B under the relation R2, this also implies that B is related to R2. B is related to A under the relation R2, since y mod of A minus B that is equal to mod of B minus A, which is not equal to 13. So R is symmetric also. R is symmetric. And then if if A is related to B under the relation R2 and B is related to C under the relation R2, then we can say that mod of A minus B is not equal to 13 and mod of B minus C is also not equal to 13. Uh, but we cannot say that A minus B is not equal to 13. We can't say this. Since why? It will not be always true. It is not true always. Since why? Example, for example, suppose we take, for example, suppose we take A as 1, B as 3, and C as 14. So then mod of A minus B that is equal mod of 1 minus 3 that is equal to 2, which is not equal to 13. So I can say 1 is related to 3 under the relation R2, and also mod of 3 minus 14 that is equal to 11, which is also not equal to 13. So it means 3 is also related to 14 under the relation R2. Uh, uh, but here, uh, but mod of 1 minus 14 that is equal to 13. So it means, so it means it is not that it is not equal to 13. So it means that 1 is not related to 14. 1 is not related to 14 under the relation R2. And here also we have to take all values A and B as natural numbers only. We have to take A and B as natural numbers only. So here 1 is not related to 14 under the relation R2, so means that R is not transitive. R is not transitive. R2 is not transitive relation. So hence R2 is not an equivalence relation also. R2 is not an equivalence relation also. So it means that R2 is also not an equivalence relation, and R1 is also not an equivalence relation. So therefore I can tell neither R1 nor R2 is an equivalence relation. So option B is the correct answer.